We have 102 of Leetcode level order traversal, and in this question we will be given the root of the binary tree, and we have to perform the level order traversal from the left to right and level wise. Now let's look at the constraints that we have, and we see that the maximum number of node is 2000, so we don't have to actually worry about getting a TLE because most of the time complexity operation will pass, even ON square will pass out, right? Now let's look at the problem. Let's say we are given this tree. Now the level order traversal will be, first we'll print out the 3, then we'll go to level 2 and print out 9 and 20. Go to level 3, print out 8, 15 and 7, and at last go to level 4 and print out 4 and 6. Now to solve this question, we have to have an intermediate memory element, like we have to use a stack or a queue. Here in this question we are going to use a queue because we have to remember, once let's say we are at the root node and we print out the root node, then we have to remember the left node and the right node at the same time, so that in the next iteration we'll be able to print 9 and 20. And in similarly we have to remember the 9's left and right and 20's left and right simultaneously, so that in the third level we'll be able to print them out. So for this we need an intermediate memory element. Here in this question we'll be using an queue. Now this is the problem that we are given. We are given the root of the tree. Now let's say you perform any of these iterative traversal orders, the in order, pre-order and the post order. You go to the next node and then you recursively call the function till you get a null, and then you print it out. No way possible that you will be able to iterate o level wise, right? You will never be able to iterate level wise. For level wise iteration, you have to remember the left and the right node in each level, so that you can print it out in your answer vector. So for this reason, we need to have an intermediate memory element. Here we are taking an queue element. Simply what we'll do is we'll push the root into the queue. So we push 3 into the queue, and then we'll calculate the size of the queue, that is 1, and then we'll run a for loop and pop all the element of the queue out. So we'll pop the 3 out from the queue and write it into our answer, and as we pop the 3 out, we'll push the left and the right node into the queue. So the left of 3 is 9, so we'll push 9, and in queue we are actually not pushing the values, we are pushing the node addresses, right? We push 9 into the queue, and then we push the right of 3, that is 20, into the queue. Now we have the size of the queue as 2. We will iterate over this loop, pop the 9 out and the 20 out, push it into the vector 9 and 20, and push the left and right of the 9 into the queue. So the left of 9 is 8, we push 8 into the queue, right is null, so we'll not push anything, and left of 20 is 15 and right of 27, so we'll put 15 and 7 into the queue. Again we'll iterate over this size 8, 15 and 7. So this is our level 3, right? We are currently at level 3. We'll iterate over this level, pop each of the element out and push all the left and the rights. So 8's left right is null, right? 8 left right is null. Push 8 into it, then pop 15. So 15's left is 4, so we'll push 4. Then we'll go to 7. 7's left is null, right is 6, so we'll push 6. So we'll have 15 and 7 in the level 3, right, in the answer. Then at last we'll have size of the queue as 2. So we'll pop the 4 out, push the left and the right. There is no left and right. Push 4 into the answer. Then pop 6 out, push left and right into the queue, put 6 into the answer. So clearly you see that we made an answer vector where we have performed the level order traversal. We have 3 first, then 9 and 20, then 8, 15 and 7, then 4 and 6. And you can clearly see that our queue is empty, so this will be our answer. Now everything that we did was, we are going to write it down in code. The first line of code will be, we defined a queue data structure of the type tree node, right? And we'll have an answer vector of vectors int, let's name it answer. Now what we'll do is, first we pushed the root into the queue, so we will push queue dot push root, then we'll run a loop. Now the condition of the loop will be, while queue is not empty, we'll run a loop. We had the queue, right? We had the queue. we push the root into the queue first. Then we have to calculate the size of the root and iterate over this length, right? And store it into a vector, right? We store this into a vector, and then we finally store it into an answer vector 3, right? Then similarly, we push all the left and right of 3, store it into a vector, and push this into the answer vector. This is the level 1, this is the level 2, and similarly we will be doing this level 3 and level 4. So for this reason, we need to have a vector. We call this vector of int level, and we have to also store the size. So we'll call int size equal to q dot size. So now we have the size as 1. So we'll run a loop, right? We'll run a for loop for int I equals to 0 and I less than size I plus plus, and we will pop this element out, push all the left and right into the queue, right? So let's create another variable of the type tree node to store the node, right? The current node that we have as queue front. Pop this queue out, pop this element out, queue dot pop. Now 3 is popped out of the queue, right? Then what we do is we push this nodes left and right into the queue. We saw earlier key when we pop 3, we push 9 and 20 the left and right into the queue. So we will run if node left not equal to null, we'll simply push it into the queue, right? Node left. Now similarly we'll see for the node right not equal to null, we'll push it into the queue, node right. Now on doing this, after taking the 3 out, we push 9 and 20 into the queue, right? Then again we'll run the same thing. We'll calculate the size of the queue, pop each of the element out, push the left and the right, again run the same loop for 3 times, pop each of the element out, push the left and the right, and we'll keep doing till the queue is empty. So after doing this, what we have to maintain is a vector. Now this is level vector. Why? Because we have to push all the element into the level, and at the end we'll push this vector into the vector of vectors and create a level. So what I mean is that initially I had a queue, I had 3 into it, I create a vector, put 3, and this is our answer of vectors, right? This is vector of vectors. We push 3 into the vector. Then we had 9 and let's say 20. This is our level 2. We push individually, we push 9 and 20 into the vector and push this vector into vector of vectors. So we have a level as 3, we have level as 9 and 20, and then we'll have, let's say, the left and right. Let's say this is size 6. So we'll have a size 6 vector, push it into the vector of vectors. So we'll have a size 6 vector here. What we are doing is every single time when iterating over the queue, we are creating a vector, storing all the elements in, storing the left and right, pushing it into the queue, and putting this vector into the final our answer vectors, right? So here after pushing the left and right, we have this as node, so we will push it into this level vector, right? This is we created a level vector, so we'll write level dot push back. We have to push the value into it, so we'll write node val. So our vector has now 3, and this is our for loop, right? This is our for loop. And after this, what we will do is we have to push it into our final answer. So we'll do answer dot pushback. This is our vector of vectors, and we are going to push a vector into vector of vectors. So we'll push level into it, and this will be our answer, right? This is our answer. At the end of this while loop, we'll simply return the answer vector of vectors. I'm going to explain you what we actually do is we have a tree. Let's say this is our tree that we have. Then what we do is we have a queue, store the first element into the queue, right? Let's say this is node 1 into the queue. Pop this queue out, put it into a vector, let's say 1, push the left and right, let's say 2 and 3, right? And pop each of these element, push the left and right into the vector, create another new vector of 2 and 3. Again, pop this element out, right? We had 4 element in the third level. Let's say 4, 5, 6, 7. Put it into the vector and push the left and right, as left and right are all null. So we'll not push anything. Q is empty. We'll break out of this loop. And we have this individual level vectors, right? Level, level, and level. And every single time we run out of the for loop, we'll simply push all these levels into our answer vector. So we have created a vector of vectors so that we can push each of these vectors into it, and we'll have the answer, and at the end we'll return the answer. Now for this code, the total time complexity will be, we have to iterate over all of the node in the tree, so it will be of the order on. And for the space complexity, we have the queue, we have the level vector, and we have the answer of answer vector. So I say key for the queue we have an time complexity, space complexity of on, and for the answer of answer vector also we have a space complexity of on, and for the level order we have another space complexity of on. If you generally don't take account of this level and the answer vector, because this is the answer that we're returning. The extra thing that we are using is this queue data structure, right? So we generally take account of this only queue data structure, so our space complexity will be on. But if you take account of all of this level and answer vectors, it will be of the order 3O of n. Now, what we did here was, we declared an answer vector. The root was null, so we'll return the answer. Created a queue, push the in the queue, push the first node into the queue, right? Then we ran a while loop till the queue is empty. What we do is we pop this 3 out, create a level vector, put it in, and push the left and right of 3. Let's say this is 3 and the left was 9 and 20. We push 9 and 20 into the queue. Again we run a loop over 9 and 20, pop each of these element out, push the left and right, and continue. And each of these level vector that we are creating, in final we will have an answer, and we'll push this all of these vectors, right? We'll have 3, another vector will have 9 and 20, another vector will have the left and right of 9 and 20, and at the end we'll return the answer vector.